It works in staging. 4 words. Every engineer has said them. Every engineer has been wrong about them. And in most cases, when they're wrong, the cause isn't a bug in the application code, and it isn't a difference in configuration anyone deliberately introduced. It's drift. The gap between what the infrastructure code describes and what the infrastructure is actually doing, a gap that opened silently weeks or months ago and has been accumulating ever since. This video is about that gap, how it forms, why it's invisible until it isn't, and why it's more dangerous than a misconfiguration you deliberately made. Because a misconfiguration is at least consistent. Drift means different things are running in different environments, and once that's true, staging tells you nothing about production. Start with the assurance that makes drift so hard to see. You run Terraform plan. It returns no changes. Your infrastructure matches your code, nothing to apply. That output reads as confirmation. It reads as, your code and your cloud are identical. But that's not what it actually says. What it says is that your code and your Terraform state file are consistent. And what it doesn't say, what it can't say without you asking, is whether the state file still matches the real infrastructure. The state file is Terraform's memory of what it last created. It doesn't update itself when someone else makes a change. It doesn't watch the cloud. It only learns about the world when you run it. So the gap between the state file and reality can grow for days, weeks, months, while Terraform plan keeps returning that same clean output. Drift enters through 3 doors. The first is the most common and the most human. 3 in the morning, production is down, a security group rule is blocking database traffic, and the engineer on call opens the AWS console and adds the rule manually. The incident resolves, everyone goes to sleep. Nobody updates the Terraform code. That change now exists in production and nowhere else. The IAC still describes the security group as it was before the incident. The code is wrong. The production environment has the right configuration. But nobody knows the code is wrong, because Terraform plan shows no changes. The state file was never told about the manual rule, so it doesn't know to report a difference. The second door is managed services. Auto-scaling groups add and remove instances based on load. RDS applies minor version patches during maintenance windows. ECS updates task definitions when you push a new container image. These changes are expected. They're often desirable, but Terraform doesn't track them unless you've explicitly configured it to ignore them, and many teams haven't thought to do this. Over time, the actual count of running instances, the actual minor version of the database, the actual task definition revision diverge from what the code says. Each individual drift is small. The compound effect is a production environment that the IAC increasingly fails to describe. The third door is the multi-tool problem. A Kubernetes operator provisions a load balancer that Terraform also manages. A Lambda function modifies an S3 bucket policy. An Ansible playbook updates packages on instances Terraform provisioned. Each tool has a valid reason for touching the resource. None of them update the Terraform state. The result is a resource that's being modified by multiple systems with no single source of truth, and the next Terraform apply will overwrite whatever the other tools did, because Terraform only knows about Terraform. Now here's where drift stops being a conceptual problem and becomes a production incident. And it happens through a mechanism that's genuinely counterintuitive, because the incident isn't caused by a change, it's caused by an apply that should have been routine. A fintech engineering team is running an RDS database. Traffic spikes. An engineer opens the AWS console and manually upgrades the instance class from db.t3.medium to db.t3.large to handle the load. The incident passes. Nobody updates the Terraform code. 3 days later, a different engineer runs Terraform apply to add a CloudWatch alarm. Terraform runs a refresh, compares the real infrastructure to the state file, sees that the instance class in production doesn't match the code, and modifies it. Back to db.t3.medium. The database is now undersized for the current load. Performance degrades. It looks like an application problem. It isn't. It's a Terraform apply executed by a different person for an entirely unrelated reason that happened to revert a change nobody recorded. This is the mechanism that makes drift genuinely dangerous. The damage isn't done when the drift is created. The damage is done when something triggers Terraform to reconcile, and Terraform reconciles back to the wrong thing. The person running the apply didn't touch the database configuration. They didn't even look at it. But Terraform did, because drift reconciliation isn't selective. It reconciles everything. This pattern appeared at real scale in July 2023 at GitLab. An old Terraform pipeline, one that had been sitting untriggered for around 3 weeks, was restarted. In those 3 weeks, the live infrastructure had continued to evolve. New changes had been applied through newer pipelines. The old pipeline didn't know about any of them. Its plan was stale. When it was triggered, it applied that obsolete plan to production. A site-wide outage followed, affecting GitLab's web interface, API, container registry, and CI runners. GitLab's own postmortem described the cause precisely. The pipeline went stale, and a configuration drift had appeared due to more recent changes being made. The pipeline applied a snapshot of the past to an infrastructure that had moved on. So here's the reframe that changes how you think about this. Infrastructure as code does not describe your infrastructure. It describes your intent for your infrastructure. What you declared you wanted, at the last moment you applied it. The gap between that intent and what's actually running is drift, and it doesn't require anyone to do anything wrong. It accumulates through incidents that get resolved and never followed up, through managed services doing exactly what they're designed to do, through the normal operation of every tool in your stack that touches infrastructure without updating your IAC state. The practical response to drift has 2 parts: detection and discipline. For detection, Terraform plan refresh only is the command you want. Unlike a standard plan, refresh only doesn't propose changes. It asks the cloud what's actually running and shows you how it differs from your state file without modifying anything. Running this in CI on a schedule, daily, is enough for most teams. Hourly, for environments where drift is a compliance concern, means you find out about drift before the next apply reintroduces it catastrophically. You're looking for the diff before Terraform uses it to overwrite production. The discipline is harder. It's the cultural practice that treats the IAC as the only legitimate path for infrastructure change. Not as a rule that everyone agrees with in the abstract, but as a constraint that's enforced in practice through IAM policies that limit who can modify production resources in the console. Through runbooks that include the step update the Terraform code as part of incident resolution, not as an afterthought. Emergency console changes will still happen. The discipline is what determines whether they're treated as technical debt that gets resolved in the next sprint, or as the quiet beginning of drift that compounds for months. The mental model to carry out of this video is this. Every change that happens to your infrastructure outside of your IAC workflow is a withdrawal from a trust account you didn't know you had. The account is the confidence that your code describes your system. Each untracked change reduces that balance slightly. The balance might stay positive for months. Then Terraform applies, and it reconciles to whatever balance it finds, which might be 0 or negative in a way you never expected.